questions do we want to see do go over on the SharkBite? The ones I see the most of 1, 2, and 4. There were some 3s in there, sorry. So translate the following expression. The quotient of 3 times a number squared and 6 less than a number. So all of this is going to be in the quotient of. Then we have 3 times a number squared and 6 less than, it's going to be that same number. So we're dividing 3 times a number squared, I'm going to call that x, and 6 less than a number. So 3x squared over x minus 6, or if you use a different variable, that was fine. Remember, with translating, that can't be done on Desmos. That's something you have to know how to do. Know the words, know how to put it back, and vice versa. 1, 2, and 4. 2 can be done in Desmos, and then 4 we'll talk about. So for number 2, if we were in Desmos, you need to put negative 15 into the absolute value. So I'm going to put it just with parentheses, but if you wanted to use n as your variable and add a slider, you could also do that. Actually, I'll do that instead. Negative 2. Your absolute value bars are here, or you can type in ABS and use parentheses. You want to add the slider, make it negative 15. And it gives us a value of negative 18. So negative 18 was your answer for number 2. Make sure when you're trying the SharkBite that you're trying to put these into Desmos. You need to practice Desmos more and more as we get closer and closer to the SOL. I should know dates, hopefully end of the week. So next week, we'll talk about that. And then number 4, state the inequality that is graphed below. So I see that this is shaded above this. So I know it's going to be something that's greater than or equal to. Looking at the slope and my intercept is positive 3. My slope, if I find points that cross grid lines, it looks like it's going up 2 to the right 3. And that seems to follow all the way through. So positive 2/3. And then because this is a dashed line, it's going to be strictly greater than. So y is greater than 2/3 x plus 3. Would be your inequality. You could double check that in Desmos, put it in Desmos, see does it look the same, does it have the same slope and y-intercept, is it dashed, is it shaded above, and it would. We're going to go over the answers to SOL A4A and B. If you don't have yours with you, make sure you're writing it down somewhere so you can take it and put those on your paper later. Alright, so just like last time, I want you to just write the answers. Don't worry about all the work, because I'm going to show some of these in Desmos. Almost all of the questions from 4A and 4B, except for 2 of them, can be done in Desmos. So for number 1, this was an equation. So I did actually solve this, but you don't need to put all that work. Just put is 0, and we'll talk about how we can find that in Desmos in a moment. For number 2 and 3, even though we haven't talked about how to find the solutions and find the roots, you should know that solutions and roots are x-intercepts. So if you were to put that function in, find the x-intercepts, and it would give you those 2 points. So you could write these as ordered pairs, write them as curly brackets, or write them as is. X equals -4/3 and x equals 2. Number 3, same thing, x equals -6 or x equals 2/5 or 0.4. And then once you have those down, go on to the next page. If you need me to go back, let me know. For number 4, I just put all of these into Desmos, and I'll show what happens here. 4 was no solution. 5 was one solution at x equals 0. 6 and 7 were both infinitely many. 8 was C, x equals 0. The only solution is 0. 9 was x equals 7, so I think that was D. Was x equals -12.5. 11 and 12 happen to be repeats of the previous 2 on the previous page, so the answers are the same. -4/3 and 2, and -6 and 2/5. Go on to the next page once you finish that. Was D, 14 was C. These are again finding the solutions. Put that into Desmos. Look at your x-intercepts. 15 was again find the solution. So those were these 2 points. And then for 16, you don't have to write what's in the parentheses off to the sides, but you do need everything else. So you were looking at what properties, what happened between each step. So from step 1 to step 2, subtraction, property of equality, or you could just write POE. Step 2 to step 3, additive inverse. Step 3 to step 4, that's really just substitution. Don't put the subtract. Step 4 to step 5, additive identity. Step 5 to step 6, division, property of equality, or POE. Step 6 to step 7, multiplicative inverse. was one that could not be done in Desmos. You have to know these properties. And when you're finished, go on to the next page for the last one. And then 17 was C, the other one that could not be done in Desmos. Okay, so I'm going to show some of these in Desmos, tell you what the next one is, and then go on from there. So with any of your equations, remember that most of the things we do in here can be solved in Desmos or done in Desmos. So equations, put them in, look at what that would be, and write that as x equals, so x equals 0, and that will tell you that answer. Anything with solutions or roots, type it in, look at your x values, and that will give you your answer. Things like this, so if I put in the original, nothing would appear. So then take each side of the equation, and you can see that these are two parallel lines. They would never cross, so that would be no solution. In this case, again, nothing appears when I type in the equation, but if I type them in separately, I see that they overlap. That gives me infinitely many solutions. And those are just some other examples. Questions on any of the Desmos, how that works for any of those, / need me to go back to any of the SLO questions? I did. Did you have one?
I think that's 11, 12.
11. So 11 and 12 are the same as 2 and 3 on the first page. Alright. Reminder for Delta Math, for practice, for this stuff, you can come get help on any of this stuff. I do have office hours today, but they're shortened, and then I have office hours tomorrow as well. The next set of SOL things that will be due on Tuesday for you guys are SOL A4C through A5B. So start at A4C and work your way through A5B. All of those are due next Tuesday. It sounds like a lot, but it's really about the same amount that you've been doing each time. Take out the notes that look like this. And then remind me, I know we went through these. If you go to this ink also. Yes. So then find the scientific notation. So go ahead and write down this. So part of this was the original definition, and I changed some of it. So scientific notation is a compact way of writing very large or very small numbers in the form a times 10 to the n, where a is a number between 1 and 10, and n is an integer. That could be positive or negative. But the a value has to be positive. Bless you. That's really what what's in the parentheses is saying. And then we're going to do a couple different examples of just writing scientific notation. And then any of those you want to see, and then we'll go into some operations of. Let's look at example 1. It says the minimum distance from the Earth to Mars is approximately 284,000 miles. We need to write this in scientific notation. Some of us are finishing this, but does anyone know how we would write that in scientific notation? See? Plus 2.84 is right, times 10, not to the power of 3. But we're looking at, this is where the decimal place would be, and we're moving it until it's between a number between 1 and 10. So that would be 1, 2, 3, 4, 5. So 2.8 times 10 to the 5th. And then example 2, the 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 268 millionth seconds shorter. Write this number in scientific notation. How would we write that one?
2.68 times 10 negative 6.
So then wherever the decimal place is, we go backwards. 1, 2, 3, 4, 5, 6. And put a negative. So if it starts with a positive number, they're all positive. If it starts with a bigger number, start at the end and move to the left. If it starts with a decimal, start at the decimal place and move right. Okay. Look in the practice section. Are there any of those we want to see go over before we start the adding subtraction?
Number 7.
Number 7. Any others? Or
2.
And number 2, this is in standard form. We need to convert it to scientific notation. Think about that decimal at the end. Move it until it's between a number between 1 and 10, so at 2. So 2.08, keep everything that's a non-zero. Hold on 1 second. And then that would be times 10 to the how many places did we move? What was your question? Yeah, we do. Questions on that before we do 1 and then 7? Same thing here. This is a bigger number, so start at the right and then move this until it's between a number between 1 and 5. 1 and 10 is what I meant. I was looking at the 5. So 7.5 times 10 to the 7. For number 7, we are in scientific notation. We're converting it back to standard form, so just writing out what the number would be. So we're going to take the decimal and we're going to move it back 2 places. So that would be 254. Any other ones we want to see from that section before we move on? My 5 looks weird. Simon, did you have a question? Number 3. Alright, so if it starts at the beginning and it keeps going until it's a number between 1 and 10, it's going to be 9.07. If it was just 900,000, then we would just do 9. And then we move that 1, 2, 3, 4, 5 places. You don't have to draw the things, but for me, I mix up zeros or miscount, so I have to see it. Moving on. We're going to be adding and subtracting scientific notation. 1, in order to do this, you have to make sure the exponents are the same. So think about this like combining like terms, kind of. If this mnemonic helps you, you can use this, LARS. If we move the decimal point to the left, we're going to add the number of exponents, or add to the exponent, it goes up. If we move the decimal point to the right, we're going to subtract, or the exponent goes down. So what we do is actually add or subtract the beginning numbers. If the exponent is the same, we don't do anything. If the exponent is not the same, then we have to change one of them. So for number 1, these exponents are the same. So we're not going to do anything with that. We are going to add 3.4 and 5.2. Go ahead and add that. Tell me what that would be. And that would be 8.6 times 10 to the second power. We wouldn't do anything to that. You could also double check this in your calculator. I'm going to do it a couple different times. As is. And in your normal calculator, it's going to give you the standard form, and you'd have to convert that back. But these calculators also have a scientific form, so if you go into mode and change normal to sci, that's scientific, and then do it again, it will change it to scientific notation. It'll have an E instead of a 10. The bases are similar, but it means the same thing. So use your calculator to double check your work. Questions on that one? Okay. Now we're going to do an example where the exponent is not the same. As a general rule, I'm going to say if you have positive exponents, use the smaller one to get to the bigger one. But if you have negative exponents, use the bigger one to get to the smaller one. But also, it doesn't matter. You can use either, just one might have more work than the other. So in number 2, the exponents are not the same, so I'm going to make this exponent become 7. In order to do that, since this went up, I have to move the decimal point to the left. Now that the exponents are the same, now I can add them. So 9.5 plus 0.11 would be
9.61.
9.61 times 10 to the 7. Do you have any questions about that? Or confusions? Do we want to see 3 or 4 before we go on to the next page? And there we come. So in number 4, we need to change one of the exponents. I'll let you guys choose. Do we want to change the first one or the second one? Okay. So if we're changing the second one, and I'm making this negative 3, that means I went down. So I'm going to be adding or moving it. Not adding, subtracting. I'd be moving it to the right. My brain mixes those up. I don't know why this is not inside line. So if I'm moving it to the right, this is now going to be 27. And then I would add those two together, 27 and 6.8. 33.8. And because of the way we did this is not an actual scientific notation because the decimal place isn't between a number that's between 1 and 10. So we have to change it by moving it back between the 3 and the 3. And because we move this to the left, we are adding 1 to the exponent, so this is going to go down. Or, I'm sorry, not down. It would go up. So our final answer has to be in actual scientific notation where the decimal place is between 1 and 10. Do you have any questions on that before we go on to the next page? Now, we're going to move on to the subtracting, and that works the same way, or similar, I should say. So, looking at let's do 8, actually. We have the same exponents. So we can go ahead and subtract 7.59 and 2.32. What would that give us? If some of you are looking at me, you should be putting this in your calculator. $5.72. And then because the exponent was already the same, we're just going to put times 10 to the negative 2. That wouldn't change. But then if we had something like 10, where the exponents are not the same. We have to change one of them. I'm going to make the second one into the first. So I'm going to make this -6. That means I would have added to it, which means I'm moving the decimal point to the left. When you're doing the subtracting and you're changing one of them, you'll realize if you did the wrong thing because you'll get a negative number, and that'll tell you you moved the wrong direction. But 4.22 minus 0.68 would be 3.54. So 3.54 times 10 to the -6, and because although if we did that, we don't have to change it again. It is an actual scientific notation. Other questions in that section, 9, 11, or 12 on the subtracting, 7, 9, 11, or 12 that we want to see when Ashley gets on. Let's move on to multiplying and dividing then. When we are multiplying and dividing scientific notation, we actually multiply or divide the numbers, but then we're using our product rule or quotient rule, so our exponent rules, to combine the 10 to the power, that power. Muhammad, go ahead. So your product rule is when you're multiplying like bases, you add the exponents. Your quotient rule is when you're dividing like bases, you subtract the exponents. And if you need the mnemonic again to adjust. So in number 1, multiply 2.8 and 1.9. And then because we're multiplying like bases, what are we doing with the exponents? Adding them. So this would become 10 to the 11. So 5.32 times 10 to the 11. And that would be your answer. Bless you. And you can double check those in your calculator also. I'll do that. In this case, no matter if it's in the normal or the scientific, because this number is so large, there's 11 places after the decimal, it wouldn't fit on the calculator screen, so it's going to put it in scientific notation regardless. Okay. Are there any other, actually let's do one more together, multiplying. Number 3. Go ahead and multiply 3.4 and 8.5. And then if we add our new exponents, -2 plus 6 would give us
-4.
+4, but yes. not in actual scientific notation because the decimal place is not between a number that's between 1 and 10. So we have to move this to the left. And because we move this to the left, we're going to add to the exponent. So 2.89 times 10 to the 5th. And if you get a number like that, I would double check it in your calculator just to double check, just to see. Are there any other multiplying questions we want to see do go over 2, 4, 5, or 6? Dividing works the same way, or a similar way. For number 7, actually divide the numbers 3.72 over 1.2. And then if we were dividing our exponents, we would do what to the, if we were dividing the like bases, we're doing what to the exponents? Subtracting. So this would be 10 to the 3rd. Any questions, confusions there? We'll do one more together, and any you guys want to see, and then we'll switch gears. I think number 10 has one where we have to change it, so let's do that one. So 2.1 over 2.8. .75, and if we're subtracting the exponents, that would give us an exponent of 4. But this is not in actual scientific notation because the decimal place is not between a number between 1 and 10. So we have to move it to the right. And because we're moving it to the right, the new exponent would be 3. 11 and 12 work the same way, they're just in a different format. Any other dividing questions we want to see, do go over, have questions about? There are practice problems on the back, and later you will have time for practice. I'm going to give you a new set, and we'll finish that last page next class. So the last thing we have to talk about in this unit is polynomial operations. Adding, subtracting, multiplying, we'll do dividing in the next unit. So when we deal with adding and subtracting, that's really just like combining like terms. So you could do it in the parentheses for adding, or you can drop them, either or, but you're not changing the exponents because we're not using any of our exponent rules. So if we were combining our like terms, 6x squared plus 2x squared would give us 8x squared. Negative 2x plus 7x would give us plus 5x. And then 3 plus negative 7. And that's it. We're just combining like terms, trying to get this in simplest form. And writing it in standard form. And that's it. There's nothing else we need to do to this. We don't change any of the exponents. Nothing else. Subtracting, you can do from the parentheses, but you have to be careful. So I'm going to show you one other way and then go back and show you how to do it from the parentheses. So So one way to avoid any confusion, you could take this negative, distribute it to all of this in the second set of parentheses, rewrite it, dropping the parentheses. So we have minus 4x squared plus 7x plus 9. And then combine your terms like that. So that if we combine our like terms, 3x squared minus 4x squared, we get negative x squared, 5x plus 7x, 12x plus 12x, and then negative 6 plus 9 plus 3. You could also do it from the parentheses, you just have to be careful with the subtracting. So 3x squared minus 4x squared, 5x minus a negative 7, and negative 6 minus a negative 9. So you could choose either way, but just be careful with the subtracting. Do we have questions on how either adding or subtracting polynomials works? On just the left side, 3, 4, or 5, are there any of those we want to see, do, go over, have questions about? Okay, let's do the right side then. So if I just had a number outside parentheses like number 6, 5 times x minus 4, what would that be? What would I do?
Just
Distribute the 5, and then what would that be? 5x minus 1. You're going to do the same thing with these other monomial terms, but because we are now multiplying x values, we are multiplying like bases, so we have to add the exponents. So negative 4x squared times x squared would give us what? What was the last one? Negative 4x to the 4th, yes. So add those exponents. Negative 4x squared times negative 5x. Positive 20x, but not squared but cubed, like you said. Because this one has an exponent, invisible exponent of 1. And then negative 4x squared times negative 3. Positive 12x squared. Bring that x with it. Don't combine anything else here. We don't have any more like terms. We don't change the exponents. That's it. That's done. We're done. Questions there? Okay. Let's do 8, and then we'll do any you guys want to see do go over. So if I were to distribute the 2x cubed, what would that give us? 14x to the 4th minus 6x to the power. Are there any others we want to see or do from 9 or 10? So then we're going to stop there, and you guys have a bunch of different practice you could be working on. So you guys have 2 Delta Maths that are due on Friday, scientific notation and polynomial operations. You have the 2 from last Friday. You have all of this practice from this set of notes. Practice from the scientific notation notes. Your SOL practice for next week. Any of that you could be working on. So use